Assalamu alaikum warahmatullahi wabarakatuh. Let me show you. So today I'll be covering how if you have authentication between two Unix hosts. So let's say this is host A and host B, and they are all running Linux OS. So in order to do the host space exchange, let's say this is first host A and they are all running some version of Linux, let's say CentOS, right? And let's say this is 7.x, and the very first step is, the idea is that this two hosts have generate public keys and private keys. So they are cryptographic keys in which you have private keys. So the cryptographic suit, if you're doing asymmetric authentication, that would require to have a public key and private keys, right? And in this case, the job of the private key is that private key signs the payload, and public key will decode it to get the original stuff. So let's say if there's a payload that's coming from A to B, that packet needs to get signed by a private key, and as long as this public key is present on the host B, that will be the only way to decrypt this packet once it comes over here. Otherwise you can decrypt it. So in order to authentication to work, if you have a public key, you can then only you can decrypt the packet, and as long as it's part of the same cryptographic suit. Similarly, we have to do, if I have to ensure that anything that goes from B to A, every payload that comes from B to A gets signed by a private key native to B, and as long as this public key is present on the A, is shared with A, the public key of B, then only it can be decrypted, otherwise it will not decrypt. So that's the concept of the host exchange, how the two Linux hosts can use the cryptographic suit of and the asymmetric encryption gives you the benefit of having two keys that will help to limit the chances of the compromise of the keys that goes. So in the symmetric authentication, you have one key that's used across all these stages. So, and here the transport, if this key get compromised at any stage, you have an issue. So that's the nutshell of how the cryptographic, in the asymmetric you have one key, whereas in asymmetric you're working with private and public keys of a particular cryptographic suit. So there are different cryptographic suits we have RSA, we have ED 95519. We are pretty much going to use RSA, and the Linux command that does generate the cryptographic suit is called SSH keygen T RSA. And let's say if I want to do 409 bit encryption, then I would say, okay, I need a key generator that has 4096 byte of encryption, can encrypt 4096 bytes, so by 4096 bytes. So this will be the command for that. You can execute on host A and do it on the host B. So you will have two suits, one for this and the other here. So there will be a public key of it, and then there will be a private. This is public and this is private. Private B, private B, public A, public B, public A. So in order for this to work, what will happen? The public B needs to come to A and public A needs to come there. That's how it will work. So once you have this thing set up, technically you can SSH. You can use, if you're using SSH as a transport, SSH is a transport protocol, RSA is the encryption suite, but once the SSH now will use asymmetric keys to authenticate between the hosts. So in this case, you can now simply point it to the so once you based on how you have set up the SSH config with SSH transport protocol, you can say that, okay, in the config you can trigger that use PAN or use keys based authentication, right? Host keys authentication. Based on this, it will fail over, and so it will try to look for. So generally, the failover is that use host key and then otherwise not PAN. So in this case, when you do a host key authentication, you do an SSH to a host. Let's say you're hosting a root to host A, and this is host B. If this is host B and this is host A, the host A will look for the public key of host B. If it's present, the authentication, assuming this has a private key here, it will authenticate. If it doesn't have the private key of the B, the authentication will fail. Similarly, we'll do it for host A. SSH root host B. So once this happens, the remote host B will look for the public key of A. If it's present, it will authenticate, otherwise it will fail over. I hope this is clear. Thank you very much for watching this lecture.